Hello everyone, welcome back to my educational channel Gyan Wizard. I am Ajmal. Today's topic is Coulomb's law. It is a quantitative statement about the force acting between two charges. When the linear size of the charged bodies are very small compared to the distance separating them, then these charged bodies can be treated as a point charge. Coulomb's law states that the force acting between two point charges is directly proportional to the product of the magnitude of these charges and inversely proportional to the square of the distance between them. This force acts along the line joining the two charges. Let us express the Coulomb law mathematically. Q1 and the Q2 are the 2 point charges separated by a distance r. Then F is directly proportional to Q1 Q2 upon r square. When we remove sign of proportionality, F is equal to K Q1 Q2 divided by r square, where K is a constant of proportionality and any positive arbitrary value can be assigned to it. But the value of K assigned will determine the size of the unit of charge. In SI systems, value of K is 9 into 10 raised to 9. This expression can be used as defining the unit of charge, that is Coulomb. When Q1 equal to Q2 equal to 1 Coulomb and distance separating between them r is equal to 1 meter, then F is equal to K. That means 1 Coulomb is the charge when placed at a distance 1 meter apart from a charge of same magnitude, and this charge experiences a repulsive force of 9 into 10 raised to 9 Newton. Then we say that the value of the charge is 1 Coulomb. If these two charges are placed in vacuum, the case number 1, if the charges are placed in vacuum, then for vacuum the permittivity of the vacuum is epsilon naught, and that is in SI unit, equal to 8.854 into 10 raised to minus 12 Coulomb square per Newton per meter square. We can express the K as 1 upon 4 pi epsilon naught. Therefore, force between the two charges F vacuum can be written as 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Now, when these two charges are placed in a medium, then what will be its impact? Let's analyze it. Then force acting between the two charges placed in a medium is 1 upon 4 pi epsilon, where epsilon is the absolute permittivity of the media multiplied by Q1 Q2 upon r square. That means here epsilon naught is replaced by epsilon. Let's find out what will be the impact on the force between the two charges. Then F vacuum divided upon F media, if we simplify it, we find out this will be cancelled out, 1 upon 4 pi, 1 upon 4 pi cancelled out, then this ratio turns out to be epsilon upon epsilon naught. Ratio of the absolute permittivity of a media to the permittivity of free space is called relative permittivity of media. That is, epsilon r is equal to epsilon upon epsilon naught. Epsilon r is the relative permittivity of the media. From here we can express epsilon is equal to epsilon naught into epsilon r. And then we can write down the force between the charges in a media is equal to 1 upon 4 pi epsilon naught into epsilon r q1 q2 upon r square. We take out 1 upon epsilon r outside, and this value turns out to be the F vacuum. That means force between the two charges when placed in a media is equal to 1 upon r times F average. That means the force will be reduced by a factor of epsilon r. Let's take an example. When this system is placed in water, for water the value of epsilon r is 80. Then if water will come out to be 1 upon 80 times the F vacuum. That means when the same charges separated by the same distance are placed in water instead of vacuum, then the force acting between the two will be reduced by a factor of 80. In conclusion, we can say that the effect of the media is to reduce the force acting between the charges by a factor of relative permittivity of the media. This is all about the Coulomb's law in this video. I hope you find this video useful and informative. Please like this video, share with your friends, and subscribe to my channel for getting notifications on new video uploaded. The subscription to my channel is absolutely free. Thank you very much for watching this video.